If you are genetically at risk for developing Alzheimer's disease in the United States, you might simply move to Ibadan, Nigeria, and see that risk abolished.
We all just tell the patients, Mediterranean diet, do it, olive oil, all the time. And we wanted to kind of back it up a little bit more. And so we looked in the literature and we found there are 12 nutrients really that seem to have a very high level of evidence that they are involved in the prevention and the treatment of depression.
Number one, terrible idea to generalize from cold and flu prevention to COVID-19. There's certainly some things that are going to work for both, but it's a really bad idea because the way that they infect cells is completely different.
So my goal really is to make these kinds of principles actionable and approachable for people of all ages, especially younger people all around the globe. That's my mission, that's my life's work, and so I'm glad to be here to kind of give you guys a bit of a Cliff's Notes foray into my findings. As was mentioned, my mom at a very young age started to develop the earliest symptoms of dementia. I had no prior family history of any kind of neurodegenerative disease, so it caught me and my family completely off guard. It was traumatic, as you guys can imagine. And with no prior family history of dementia, I was at a loss. I couldn't explain it. So as somebody who's perennially curious and optimistic and resilient in the face of trauma, I began to roll up my sleeves and do the research for myself, because I was met with abject disappointment in every clinician's office that I had the privilege to be in with my mom. So because I had no prior family history of any kind of dementia, I began to ask myself what it was about my mother's environment that may have pulled the trigger on a genetic weakness in her that led to her being the first person in my lineage to develop dementia. I started to look at parts of the world where they have Alzheimer's risk genes, just like we do here. About 1 in 4 of us sitting in this room have a gene that puts us at higher risk for developing Alzheimer's disease and other neurodegenerative conditions. But interestingly, in other parts of the world, like in Ibadan, Nigeria, that same genetic risk factor is associated with little to no increased risk for developing Alzheimer's disease. So just to put that another way, to rephrase that so you guys truly understand it, if you are genetically at risk for developing Alzheimer's disease in the United States, you might simply move to Ibadan, Nigeria, and see that risk abolished. That's kind of amazing, right? So I started to think about what our ancestral diet might have been like. You know, the kind of diet that human beings might have consumed during the time in which our magnificent brains evolved, right? I mean, certainly our environment has become a lot different, but we ate for millennia, and our diets and our lifestyles led to the evolution of the flagship product of Darwinian evolution, as I like to call it, the human brain, which each one of us is heir to, this magnificent supercomputer. But about 10,000 years ago, we reached a turning point in our evolution where, after millennia of growing, our brains actually began to shrink, ultimately losing the volumetric equivalent of a tennis ball. So just to put that another way, so you really get to understand it viscerally, we ate for a certain way for hundreds of thousands of years that led to the growth and development of the modern human brain, and then we turned our backs on that diet, and our brains began to shrink. We became settlers. We went from being hunter-gatherers to being domesticated by the handful of crops and animals that we could cultivate. And that paved the way for the fact that today, our diets are composed primarily of calories from just 3 plants. Can anybody guess what those plants are? We've got 2 of them. One more, last one I haven't heard. Not soy, rice. Yes. So today, 60% of the calories that we consume come from just 3 plants: wheat, corn, and rice. And not only that, but these plants are usually pulverized and processed and ground into a dust to form the ultra-processed foods that we now eat with abandon. It doesn't help that our dietary guidelines advise us to consume these kinds of foods at every single meal. We're told to load up on healthy whole grains. Well, recently, Cochrane, which is known for their unbiased, systematic reviews in partnership with the World Health Organization, found that there was actually never any good evidence that grain consumption benefits heart health beyond just epidemiological studies that show that populations that eat, higher amounts of whole grains tend to have better health. But there we can look to something called a healthy user bias. People who eat highfalutin grains like quinoa and brown rice, they tend to do other healthy things in their diets and lifestyles as well. But when we look at randomized controlled trials, which are the kinds of trials that can prove cause and effect, which this meta-analysis actually chose to look at, they found that there's insufficient evidence from randomized controlled trials to date to recommend the consumption of whole grain diets to reduce the risk of cardiovascular disease. And of all the researchers that I've spoken to about what causes Alzheimer's disease, it seems that vascular dysfunction of, the network of blood vessels that feed your brain nutrients and oxygen, may be one of the earliest things to go awry in the body. Now, as I mentioned, these grains are packaged and sold to us in our supermarket aisles. Many of these packaged products make health claims, right? They compel you to want to buy them because they've got that beautiful red heart usually on the box, right? These foods now make up 60% of the calories that we consume worldwide, ultra-processed foods. These foods are dangerous for a number of reasons. I'm going to tell you guys why. Before we get to that, this is one family's food consumption for a week. Yeah, this is highly problematic. See, what these foods do is they drive a process in the body called inflammation. Has anybody heard of inflammation? Yeah. So inflammation is like having a forest fire in the body. It's actually meant to occur, like those Tide spot cleaning wipes when you get a stain on a piece of clothing? Inflammation is naturally meant to spot clean cuts, wounds, bruises, and things like that. But the problem is that our immune systems are responding to the fact that our diets, that there's this predominance of ultra-processed foods in our diets. And so now we have widespread chronic inflammation in our bodies. It's like a forest fire. It's the equivalent of a forest fire in our bodies. And our brains sit directly downwind of that fire. Now, our bodies are incredible, right? Like, we didn't make it here through millennia to be taken down by this process necessarily. We have an ability to repair from the damage wrought by inflammation. But the problem is our bodies need the appropriate ingredients to be able to do that efficiently. Now, going back to these ultra-processed foods, if you look on the backs of most of the packages of them, you'll find that they're all fortified with synthetic vitamins. And that's because these foods are nutrient deficient. And it's the reason why, the fact that our diets are based on these foods, 90% of Americans are now deficient in at least one essential nutrient. So even though our bodies have the ability to defend against chronic inflammation, or at least acute inflammation, we're seriously handicapping our bodies in profound ways. And so it's causing this damage to our bodies and ultimately to our brains. These foods also drive the chronic elevation of a hormone in our bodies called insulin. Now, insulin is not bad, but when it's chronically elevated, it drives the storage of fat. Now, many people today are overweight or obese. In fact, 2/3 of US adults are either overweight or obese. For the first time in human history, there are more overweight adults than there are underweight. Now, the problem when we consume these kinds of foods, again, the packaged processed foods made of ground up rice, wheat, and corn, and these kinds of foods, is that they cause our fat cells to become sort of like a subway turnstile at rush hour in Midtown Manhattan. Calories can flow in, but they can't come out. And this is problematic because our brains love to use fat for fuel, but we're basically blocking our brain's abilities to use fat for fuel because we're always eating these high carbohydrate, ultra packaged processed foods. Now, when a baby is developing, a baby's brain loves to use fat for fuel. In fact, mother's milk is full of a type of fat called medium chain triglycerides, which turn into ketones in the body. Has anybody heard of ketones? They're kind of trendy right now because a lot of people are on these ketogenic diets. Halle Berry, I've discovered, is on a ketogenic diet. The Kardashians are on ketogenic diets. very few people actually know what ketogenic diets are, but they basically supply fat to the brain. The brain loves to use fat as a fuel source. But the inhibition of fat metabolism by high carbohydrate diets may actually be one of the most detrimental aspects of modern diets. And part of this has to do with the fact that the brain's ability to use fat is shunted by chronically elevated insulin. Chronically elevated insulin is problematic for many reasons. It's pro-inflammatory. And published in the Journal of Alzheimer's Disease, it was suggested that 40% of Alzheimer's cases alone may be attributable to chronically elevated insulin. So for the next few slides, for the remainder of my talk, I'm going to give you guys an antidote to the standard American brain-shrinking diet by telling you the foods that you should actually be eating every single day. I call these foods the genius foods. Now, genius foods is not a scientific term. It's sort of like superfoods. But I thought that if I could get people to think about the foods that are most beneficial to the brain, well, then you're going to be able to choose these foods at every meal and maybe kind of elbow out the foods that are less supportive of optimal brain function and brain health. So for one, we've got dark leafy greens like kale. You should actually write these down. I see some people taking notes. I'm going to go over the 10 genius foods plus one bonus food. So you're going to get 11 foods. You should write these down because they're all very beneficial in different ways. So we've got dark leafy greens. Research out of Rush University has found that people who consume a large bowl of dark leafy greens every single day have brains that tend to perform up to 11 years younger. Okay? So what you want to do every day, a rule that I lay out in my book and in my work, is that you should try to have a big salad every day. Easy, right? Try to fill it with dark leafy greens like kale, spinach, and arugula. Kale is actually very high in two compounds called lutein and zeaxanthin. These are carotenoid compounds, basically plant pigments, that have been shown in a University of Georgia study to boost the processing speed of your brain. I'm going to come back to those two carotenoids because they're found in some of the other foods that I'm going to mention as well, like eggs. When an embryo is developing, the first structure to assemble is the nervous system, which includes the brain. So an egg yolk literally has everything designed by nature to support an optimally developing brain. It's amazing. It's no wonder that egg yolks are considered nature's multivitamin by some. You want to eat the yolks, folks. The yolks are very healthy. They're very good for you. Grass-fed beef. Now this is very, I think, controversial because red meat, you know, we're always told to limit our meat consumption. And I'm not a proponent of eating lots and lots of meat, but I definitely think that it should be incorporated into your diet. And this is in contrast to grain-fed factory farm meat. I am not endorsing that in any way, shape, or form, no way. But grass-fed organic beef is rich in a number of compounds that support brain energy metabolism. The fat of grass-fed beef is also very rich in those two carotenoids, lutein and zeaxanthin, which are not only good for your brain health, but your eye health and your skin health as well. Grass-fed beef has 3 times the vitamin E of grain-fed beef. Vitamin E, there's a strong relationship between the consumption of foods that contain vitamin E and better brain health. Why? Because vitamin E is a fat-soluble antioxidant. Again, it's a fat-soluble antioxidant. Why is this important to the brain? Because the brain is made of fat. And it's not just made of any type of fat. It's made of a fat that's very prone to oxidation, which is a process in the body that's sort of like accelerated aging. We want to consume more antioxidants, especially the fat-soluble ones. Wild salmon. Wild salmon is full of the building blocks that your brain requires to grow healthy new brain cells. Avocados. Avocados have a higher concentration of fat-protecting antioxidants than any other fruit or vegetable. They also have twice the potassium of a banana, which supports cardiovascular health, which is very important for brain health. And also a very good source of fiber, which is going to fill you up. Extra virgin olive oil. Extra virgin olive oil is actually a fruit juice that human beings have been pressing from olives for thousands of years. Unlike these newer industrial oils like canola oil, corn oil, and soybean oil, which I'm going to use the word toxic to describe, extra virgin olive oil is actually quite healthy, and it's a staple of the Mediterranean dietary pattern, adherence to which is associated with a robust risk reduction for developing dementia and Alzheimer's disease. Mushrooms. Mushrooms are incredible. There's some really cool epidemiological research coming out of Asia, where they're finding that people who consume mushrooms habitually have dramatically reduced risk of developing both dementia and a condition called mild cognitive impairment, which is sometimes referred to as pre-dementia. If you eat about a half a plate of mushrooms a week, they've found that over 6 years there's a 50% risk reduction for developing mild cognitive impairment, which correlation isn't causation, but empowering to know nonetheless. Cruciferous vegetables, like broccoli, kale, cabbage. These vegetables give your body the raw materials for your detox pathways. A lot of people are spending money these days on detox teas and the like. Cruciferous vegetables are the ultimate detoxification stimuli for the body. I'm going to try to rush through the next few slides because I've only got a few minutes left. We've got berries. I'm a huge fan of berries, blueberries in particular. The color in blueberries have been shown to accumulate in the hippocampus, which is the memory center of the brain, and protect it against oxidative stress and aging. People who consume more berries tend to have better memory function. Animal studies validate this fact. Dark chocolate. I usually get cheers from the audience. Cocoa flavonols, very beneficial, supportive of heart health. Again, habitual cocoa consumers tend to have better brain function, and there's even a correlational study that's found that countries where there's higher per capita chocolate consumption, they have higher numbers of Nobel laureates. So it's a fact. Almonds. Again, a very important source of vitamin E and magnesium, which is important for DNA repair enzymes in the body. Nuts in general are important. You just want to make sure that they're either raw or dry roasted. Raw or dry roasted. Generally, if they're roasted but not dry roasted, that means that they're fried, usually in very unhealthy oils. Now, where's the hard data that all of these kinds of changes are going to actually minimize your risk for developing cognitive impairment? Well, I had the pleasure of going to Stockholm, Sweden, where I interviewed the lead researcher behind the finger study, which is some of the best evidence to date that our choices matter when it comes to our brain health. By adhering to a battery of these kinds of, a dietary pattern similar to the one that I've described, they found that in an older population of adults that were at risk for developing cognitive decline, that eating a healthy diet compared to the control group that was just given standard of care, they had an improvement in their brain's processing speed by 150%, and an improvement in executive function by 83%. Or you guys live in Aspen, there's lots of great hikes. I live in Los Angeles, we have the same. But I'm also a big fan of resistance training. And I like to talk about resistance training in particular because it's underappreciated in my view. Having stronger muscles is correlated to better brain health. We can see this in a number of studies that have come out recently. And not just brain health, but mental health. Published over the past year, we've had a number of really important and well-done meta-analyses that have found that not only is aerobic exercise critically important for treating depression, but resistance training, which I've highlighted in the bottom two, are critically important for a treatment as a potential treatment for depression and anxiety. So, really, really critical stuff. Get to the gym. It's medicine for your brain. And in fact, exercise is now a new treatment guideline, according to the American Academy of Neurology, that a physician can write on a prescription pad to prescribe to patients with mild cognitive impairment. There's no other FDA-approved drug, as I sit here talking to you guys, for the treatment of mild cognitive impairment. So exercise, again, truly is medicine. Now, when I began my research, one of the most startling things that I've found, and I experienced in myself, is that brain health is something that it's a huge knowledge gap for people. And I've sort of made it my mission to fill that gap. AARP performed a study where they found that many people will concede brain health is critically important, but very few people actually know how to boost it. So I'm super excited that the Brain Institute is here pivoting towards brain health. I think it's critically important. It's the most important conversation, I think, of our time. And a new dementia case is diagnosed every 3 seconds, which is startling.
A lot of data started coming out about seafood, the omega-3 fats, and at that time I didn't eat seafood. And it just got me really thinking, like, how do we incorporate food and nutrition into a clinical model for mental health? And that's really been like the question I've been thinking about then, really both day to day as a clinician, where you're sitting with patients and you're looking for everything you can bring to the table to help them get better. And it's just like, wow, we don't talk to patients about food. We don't talk to them about depression and anxiety and lots of ways to help with that. I mean, I do everything in mental health. I prescribe meds. I do lots of psychotherapy. We do coaching in our practice. I mean, and I've seen all of those things work, but it just feels like food is one of these foundational things that makes a difference. Imagine you're treating somebody with depression and they're just eating nothing but fast food. They're not ever cooking for themselves. They're not shopping, right? You just instantly begin to, if you're a clinician, see opportunities there. And so that's really in a lot of ways what nutritional psychiatry has been about for me over the last decade is how do we help more people learn about this new science? And then how do we through some of these efforts like the book really help to mobilize folks to make changes in their own life?
I love that. You kind of alluded to, or like when we first started talking about how certain mental states can actually dictate, or at the very least, influence our food choices, right? Like when we're stressed, we tend to reach for certain comfort foods, right?
Yes.
Yeah, it's very interesting. But would you then also say at this point, there is a strong enough body of evidence that we can say that the inverse is also true, that the foods that you reach for can influence your mental states?
I think the answer is a definitive yes. I think anybody who wants to debate that answer, I'm looking forward to that debate because unlike maybe when we first met, and there was a little bit of evidence, correlational evidence, which doesn't end up meaning a lot sometimes. Now we have multiple randomized clinical trials. We have trials where we take individuals, not me, but mainly Felice Jacka's group, but me is the larger world looking at how do we help people beat depression and anxiety. And the best trial of this so far has been the Smiles trial and the Healthy Med trials. Those two trials, between the two of them, have well over 300 patients where they take individuals struggling with depression who are in some sort of treatment, usually psychotherapy or an antidepressant, and not getting all the way better. So not reaching the criteria for what we call full remission. And that's what you want. That's like, I don't feel like I have depression anymore at all. And a lot of patients don't get there with just traditional therapy and meds. And what they found is adding on the Mediterranean diet improves, actually, in the Smiles trial, 33% of individuals went into full remission. If that was a medicine, it would be $1 billion medicine right away. And then a number of trials have followed that. The most recent, interestingly, came out last, what, 2 falls ago now, looked at college students. They just showed them a video, like depressed and anxious college students. It's like, hey, here's how to eat to help your mental health. Eat more of a Mediterranean style diet. Here's what that is. Here's more plants. Here's a way to make plants tasty. And they gave the students a little box, this box of like nut butter, nuts, olive oil, turmeric, cinnamon, and then called them a week later, like 5 minutes, like, hey Max, like you watched the video, bro. Like you eating the nut butter is cool. Like you tried out the turmeric. And they called him a week later. And they found that over 6 months, just that intervention, talking a total of 23 minutes, led to significant decreases in depression, anxiety, and stress for the college students. So we're starting to have that kind of data. And then on top of that, we just have more knowledge about mechanistically how things like antidepressants work. Just a paper came out in Nature showing that really antidepressants are both powerful anti-inflammatories, but also induce brain-derived neurotrophic factor. People always think about them as related to serotonin. What doesn't make sense about that is your serotonin in your brain synapse, it goes up in like an hour. But you don't get a clinical effect with an antidepressant for about 3 to 4 weeks usually.
Very interesting.
So there's something going on there, and what most definitively seems to be now is that you're decreasing inflammation and you're increasing neuroplasticity and brain growth.
Hmm.
It is one of the pathways by which those meds work. And what's exciting about that is that's the pathways by which food works. It's also the pathways probably by which exercise works. And so we now have this kind of arsenal of stuff that when we think about, all right, how do we influence mental health? Well, you can probably all agree having a brain that is not dealing with inflammatory factors, having a gut that's healthy, and having a brain that's in what I call in the book, I call it grow mode. And that just means that your brain is best positioned, if possible, when you encounter stressors. Because I'm a psychiatrist, and I'm sure everyone listening knows this. Like, life's full of stressors, and no matter how good you get at life, you still encounter lots of stressors. So the idea is that if the lens by which we kind of see those stressors and then biologically experience them is something that we have, not full control of, but some control, food kind of makes that lens or shapes that lens in some ways. So yes, that was a long-winded yes.
I really appreciate that. I'm really glad that you brought up these two mechanisms by which it's now, um, we're starting to see are the potential mechanisms by which SSRIs work in a subset of patients to which they are prescribed to. Right? There's like the increase in BDNF, which you mentioned. Which can you just for listeners that are not familiar with BDNF, what is that essentially?
BDNF is the main, what's called neurotrophin. And a neurotrophin is a nerve growth factors. And so these are proteins that are coded for in our DNA. And when they get expressed, they create these molecules, these proteins. And BDNF does a variety of things. It induces the birth of new brain cells or promotes that in the hippocampus called neurogenesis. And then it also helps brain cells with like brain cell resilience. Like I think about BDNF a little bit like, like a good coach, right? That like if I'm a little brain cell, when I'm like not, still like too much for me, like too much cortisol, too much bad news, I just can't handle the stress. I'm gonna call it quits. And they're like, hey, you can still do a little brain cell. And BDNF kind of coaxes brain cells to stay alive. And then the most important thing, I guess, is to make new connections. That if you
Hmm.
think in this very concrete way, what does our brain do? How do we know a healthy brain? A healthy brain is really connected up. You're connected to yourself and your own intention and your focus in your work. You're connected to the people around you that matter in a meaningful way. And so I like this idea of thinking of the brain as our organ of connection, and that you can even see that on the biological level. BDNF increases brain connections. If you look at all of these kind of new wave of medications and molecules being looked at for antidepressant effect, ketamine, psilocybin, all of these, they all seem to function really by inducing rapid sprouting of neurons, and we generally understand that to be a BDNF regulated process.
That's amazing. Exercise is one of the most well-established ways of upregulating BDNF, right?
Yep. I like that one because we feel it. Like you get done with it, you get done with that workout, and not that that's immediate BDNF. We used to think like, oh, you don't feel it that fast. It's like, well, you feel ketamine that fast when it works as an antidepressant. It works within a few hours usually, and so it's kind of remarkable. Um, but yeah, I love the way that exercise, like food, can really be one of those things. When you see people get better and beat depression, not always, you can beat depression in other ways, but that's usually part of the package that people bring to the table.
Yeah. Are there foods that you're aware of that can also lead to an increase in BDNF?
So the way that we back into foods is looking at the nutrients that can increase or influence the BDNF gene.
Hmm.
And so I know of six nutrients with significant evidence that they influence BDNF, or there's a molecular pathway by which they do. And let me see if I can name all. There's zinc. There are the long chain omega-3 fats, but particularly DHA. Magnesium. There's actually a paper where they look at the mechanism of ketamine, and they also look at the mechanism of magnesium, and they're pretty close. There's a flavanol, or some of the flavanols, the polyphenols can induce, and there are a couple of different ones of those that seem to be able to help with BDNF. That's for, I'm gonna guess, oh, I think B12, and then I'm gonna guess iron is my last one, but I might not remember Max.
I think that was more than that.
That
What I
that was
think
six.
that was six.
That was
Okay,
six.
interesting.
Let me just go back and say five.
Okay.
There were and four I'm sure of.
Well, I love that we have these nutrients because they're pretty ubiquitous, like in the food supply, if you know where to look for them.
Yeah, I think I mean, as a physician, we don't get a lot of training in nutrition, but actually, my last book, in some ways, was just really about that. Here are these 21 nutrients that really matter. And in this book, Eat to Beat Depression and Anxiety, I focus on 12 because we looked in the literature. Dr. Laura LaChance and I did a little paper called Antidepressant Foods. Because as we were starting to think about teaching clinicians about this, all right, this makes sense. There's lots of biomolecular pathways that support this. Now there's lots of correlational and now clinical data. Let's start talking to clinicians and see what happens. And then we kind of scratched our heads like, well, what foods are you going to tell them to prescribe? And be like, you all just tell the patients Mediterranean diet, do it, olive oil all the time. And we wanted to kind of back it up a little bit more. And so we looked in the literature and we found there are 12 nutrients really that seem to have a very high level of evidence that they are involved in the prevention and the treatment of depression.
Hmm.
So you look at something like zinc. Populations that eat less zinc have more depression. You look at people who get depressed, they have overall, as a population level, lower levels of zinc. You look at what zinc does. It induces BDNF. It's involved in like 300 different chemical reactions in the brain. And then you get to, okay, well, what foods have the most zinc? And the plant-based foods with the most zinc are things that oftentimes get concerned in terms of absorption. But in the animal world, it's oysters. And then you think, well, what other nutrients in an oyster? And you get this real quick basic lesson of nutritional psychiatry, which is about nutrient density, where when you look at an oyster, you see long-chain omega-3 fats, you see a plethora of B12, you see selenium, you see zinc, you see iron, you see almost all the nutrients I just named that seem to promote BDNF. And so as you think about then seeking a diet where for the fewest number of calories, you're getting the most nutrients for your brain. And that's really where the food recommendations from Eat to Beat Depression and Anxiety come from. Just taking these foods and thinking, or rather taking these nutrients and thinking, what are the foods with the most of them? How do we help people integrate those foods into their life in a meaningful way? And most importantly, I think the piece that really gets missed, and I do think sets nutritional psychiatry apart, is we start to really then look at food categories. So you don't have to eat the kale and the oysters if those are disgusting to you. And as a psychiatrist, I'm really interested in your joyfulness as an eater. There's this chapter in the book called Eat or Heal Thyself, where I just think right now in particular, and I think makes you know this as well as anyone, better than most of us, right? Is how kind of confused people are, how influenced people are, um, how badly people are hurting in terms of really wanting to put their effort into changes in their life and their food that work. And so it's really important to me to present the information in a really balanced way that helps people transcend some of these debates that are not the right debate, that you should eat meat or eat Impossible Burger. I don't think that's the right debate to be having right now. The right debate that we should be having right now is how can we all support one another and ourselves to really get motivated to feed our mental health and feed our brains. I think that's the, at least that's what I hope shifts and happens.
Yeah. Well, you mentioned oysters because they are very rich in zinc. What are some other foods that are on this list of 12? Is it 12 foods to beat depression?
Well, there's the power players in the book, and those are the foods that really I wanted to highlight because they represent food categories so well. So
Well, we don't want to give them all away, but
we
what
can
about
give them all away. This is the Genius Life podcast. I mean, I was thinking on the way over here, I was thinking like how I think all of the all of probably the foods on my list are foods in your books too. I think there's a pretty. I think there's a lot of bias support here, but I'm okay with all the debate going on. I'm okay to be here. This is a safe place. It feels like.
it is, and it's okay if there's overlap. And you have 12 foods. I only have 10 genius foods. So you found at least 2 foods
Well, maybe
that were
maybe
not on my radar when I wrote genius foods. So I wanna get into. We can go through 6. What are 6 of the? You already listed oysters, but what are some other foods?
Yeah, let's talk about some of the other foods that I think are important in terms of why they're on there conceptually. Because again, whether those are the foods or not for you, it's more of what do they represent. Like, why is kefir on the list? It's a fermented dairy product. It's a more liquidy than yogurt. It also has more colony forming units than really any other food. If you
Hmm.
look in the sciences, when you're thinking about a probiotic, you'll see it's got 2 billion or 50 billion or 100 billion. Well, the live bacteria is in kefir. There are some actually studies showing a serving of kefir can have up to 1 trillion colony forming units,
Wow.
which I'd never seen in a probiotic. But I also think it teaches us something about the importance of fermented foods and where they come from, what they meant to us historically. So kefir is on the list, as are other fermented foods. Cashews.
Wait, before you go into cashews, kefir, there are a number of different types of kefir available to your average consumer. We have like coconut
Oh wow, that's
kefir.
right.
We have
Yeah,
dairy
I know.
kefir.
Yeah.
Is there a preference? What if you're trying to be dairy free?
Then I don't think you should drink a dairy kefir. I think that's not going to be good for you.
Fair. Is coconut kefir a good second place option?
I think so in the sense that as you ferment really anything, whether it's kombucha, you're fermenting tea and sugar, whether it's you know what do they ferment in the coconut fermented drink? Is that coconut milk?
That's a good. Well,
Coconut,
coconut water has
coconut.
sugar in it, so I
Yeah.
would imagine it's a substrate for some.
So I think
Sure,
that
there's
those
some bacteria out there
I
be
think
happy
those
to
are
eat that.
interesting replacements. I think that one of the nice things about kefir, and I guess why it's on the list, is I think it's an interesting way to be provocative about the dairy concerns that sometimes people have. Because as you ferment dairies, you tend to get rid of lactose, just like when you ferment glutinous materials, you tend to get rid of gluten. There's actually a study of a double gluten fermentation that removed all of the gluten. You could literally label it as gluten free.
Wow.
So fermentation's as a powerful thing.
Hmm.
But yes, I think the short answer is if kefir is not your thing, find some fermented foods and experiment with them and see what can work for you. Um, cashews have just been a big part of our house since we started having kids. Because when you have kids, there's this whole like anxiety trip. When do you feed them nuts? And it's like a deep rabbit hole to get into on the internet. And so we started being really strange parents. We started like chewing up nuts and feeding them to our children, like little like kind of like birds, I guess. Is I don't know. Probably it's gonna horrify everyone, but yeah, that's what we did. And then cashews entered our life just because breast milk tends not to have as much iron. It's definitely by far the best food for babies, but cashews are a higher iron containing nut. So certainly not the only iron containing food we gave our kids, but one of them. Um, some of the other foods on there, red peppers, just looking, vitamin C was one of the nutrients made the list, and everyone goes to citrus. That's a fine choice, but I just like peppers and using them in food, and red peppers just have a plethora of vitamin C.
Did
Um,
you know that red peppers, like all nightshades, have trace amounts of caffeine, not caffeine, nicotine in them?
I have heard that, and yeah, I think that that's that's one of those fascinating things you see in the plant world, this homology that exists, right? Where you get things like, melatonin in plants.
Cherries,
Yeah,
right?
actually a lot of different foods. Cherries have a little tiny bit.
Hmm.
And they all actually have they all have like picograms. It's like little tiny amounts. But it's just it's fascinating that we think about how intertwined we are with these other organisms and how we share common molecules. It's I think really inspiring. I think it's also one of the reasons I end up being, I wouldn't say a Luddite. I just really trust traditional foods. Is I just think, look, there's a lot been going on that you don't have any idea about, you and me, right? The microbiome. 10 years ago, we wouldn't even mention that word. We were like bugs in your gut, and those wouldn't be part of talking about depression and anxiety. And so I trust natural foods because I think that's where we came from, and that's what our brains have been made out of. And currently, there's a lot of reasons, a lot of things informing the mental health epidemic, but certainly one of them that looks real suspicious to me in the data has been the way that we've changed how we food nourish our brains.
Yeah, I couldn't agree more. Um, that's a big rabbit hole to go down. But yeah, I mean the uber hyper industrialization of our food supply, our just chronic exposure to industrially produced toxicants, whether they're endocrine disruptors or heavy metals, you name it. But that's the subject for a different conversation. We were up to bell peppers.
But let's talk about some other foods. Let's definitely talk about some seafoods. And that was the book ends with a 6 week plan really to try and do what we do in our clinic, which just help people jumpstart their motivation, transcend all of the strange voices we hear in our heads about and on the internet about food and what we should do, and really think about you and your life, where you are, what goals you have, and how you can evolve as an eater. And so seafood is a really important category.
Hmm.
It is where you find these long chain omega-3 fats. You also just find a lot of nutrient density when you look at salmon or anchovies or oysters or clams and mussels. And so anchovies and wild salmon were the two that I thought were most accessible to people, and really that you can find in very budget friendly ways. There's a
Hmm.
lot of course, concern about, are these foods accessible to people? That's one of my favorite recipes in the book is the salmon burgers. You ask if I'm a chef, and let me tell you, I feel like the best chef in the world when my children eat these wild salmon burgers because you can do them as little croquettes and they're delicious. You can do them with a variety of different, they're an almond flour or a coconut. I mean, you can really use a lot of different bases. In the book, we make them a couple different ways, a honey soy and a kind of dill salmon burger. But they're in there because of nutrient density, because of the omega-3 fats, and also just because seafood tends to, if you look at all these traditional diets that are really, really healthy for the brain, Japanese diet, a Norwegian diet, the Mediterranean diet, there's just more seafood in there than Americans tend to consume.
So I think it's important to acknowledge at the outset that at the moment this virus just appeared out of nowhere over the last couple of months. So there exist zero randomized controlled trials testing anything that we can do for prevention, and even what's done in the standard of care and practice has no actual clinical trial basis to it yet. I mean, there's ongoing clinical trials of all the stuff they're currently doing. So no one really knows, and all we can do is what there is a huge body of evidence on mechanistically how does the virus work, what is it actually doing in our bodies, and so we can dig into the enormous volume of decades of research on nutrition and herbs and foods and what they do in our bodies, and then months of research on there's so much research coming out on COVID-19 that no one person could possibly read it all. I get up every morning and I look at the preprint site where all the articles that are destined for peer review are coming out before they're peer reviewed. Then they wind up on PubMed. There are dozens to sometimes hundreds of new studies on COVID-19 that come out every single day. So over the last couple of months, we have an enormous volume of COVID-19 research. And then we also know that it has known similarities to and differences from other viruses. So for example, the actual name of the virus that causes COVID-19 is SARS coronavirus 2. It is the sequel to SARS coronavirus, which we could now call SARS coronavirus 1, which caused the SARS epidemic back in 2003, 2004. And so it's 87% similar. And so, you can look at you can say, for example, that the way that this coronavirus enters cells is identical to the way that SARS coronavirus entered cells. But there's only one other coronavirus that enters cells in that way. Meanwhile, it's completely different from how influenza enters cells, completely different from how cold viruses enter cells. And then there's other basic things that where like all coronaviruses are lipid enveloped. Flu viruses are, cold viruses aren't. Or well, actually, some coronaviruses can cause colds, but the rhinoviruses cause most of the colds, and they're not lipid enveloped. So we can look at all that research and we can say, okay, what do we know about the way this virus behaves? What do we know about what worked for SARS and what didn't work for SARS? What do we know about what we thought might have worked for SARS and really tricked us because it was deceiving, right? So I think a few things that we can say are, number one, terrible idea to generalize from cold and flu prevention to COVID-19. There's certainly some things that are going to work for both, but it's a really bad idea because the way that they infect cells is completely different. And as an example of that, I have always recommended and practiced high dose vitamins A and D for cold preventions. There's really good research going back to the 1940s that if you take people who get 7 colds per year, so very high frequency cold sufferers, and you put them on tens of thousands of IU of vitamin A and vitamin D each, their cold incidence goes way, way down, right? So high dose of vitamins A and D are very protective against colds. There's a concept out there called the vitamin D hammer. As soon as you get first symptom, take 50,000 IU of vitamin D, boom. People say it, works like a charm for the flu.
Wow.
There's no clinical trials of that, but there's anecdotes for it. There are randomized controlled trials showing that vitamin D prevents the flu, right? So for colds and flu, really good evidence on vitamins A and D. However, we know a few things that should make us extremely cautious about generalizing from that to COVID-19. So first of all, part of the way that vitamin A protects against viruses is to be involved in the cell's ability to detect the virus and then mount an interferon response. And we know that the SARS coronavirus and the MERS coronavirus, and most likely the SARS-CoV-2, the virus that causes COVID-19, basically directly undermine the ability of vitamin A to stimulate the interferon response. It's part of like a really broad network where they have like a whole suite of mechanisms to evade and undermine the host from mounting an interferon response. That allows them to massively multiply, and then they wind up hijacking the interferon response at a later time to actually cause massive inflammation that contributes to disease.
So what is the interferon response? What is that?
So basically the cell will constantly monitor for signs of the presence of virus. One of the key signs of the presence of a virus would be double-stranded RNA, because when we make RNA, we're reading our own genome, which is made of DNA. We copy the gene and make a transcript of RNA that's a single strand that then gets read by a ribosome to produce a protein. So through our own normal processes, we don't have double-stranded RNA. However, a virus has to read an RNA template, hijack our machinery to produce an RNA transcript from that. So because the RNA virus is copying RNA to make a duplicate RNA copy, you wind up with the presence of double-stranded RNA. The cell says, "Oh my God, this is a virus." So the cell starts producing interferon, which is one of many small molecules called cytokines, and it is one of the key players in promoting the entire antiviral response. And so with most viruses, so this gets into a second thing to be real careful about generalizing. So interferon in general makes SARS-CoV-2, SARS, and MERS potentially very different from most other viruses. And this is most well studied in the case of the first SARS virus. So in almost every virus, interferon is very protective. The cell detects the virus, the cell mounts an interferon response, the interferon response mounts the entire immune response to crush that virus. Okay, so in the case of SARS, where this is really well studied, not only does the virus undermine, it literally has about 15 different mechanisms to undermine the cell's initial interferon response. That allows it to escape the immune system. It multiplies massively in the lung, but then it accumulates. All these cells called macrophages start getting recruited to the lung to try to deal with that virus, but they're late. They're like the fire department that got to the burned down house. Wow. And so those macrophages, once they build up to a very high level, at a later time point, they mount an enormous interferon response. It's way higher than what should have been there. And this late, delayed, massively overshot interferon response that came too late then is a major player in initiating what's called the cytokine storm, which is a huge burst of all the wrong type of inflammation that causes lung damage and ultimately causes death. So what I find to be one of the most compelling reasons to be exceedingly cautious about generalizing from something like the flu to something like COVID-19 is a mouse study that was done back around the time of the first SARS virus, where they engineered mice to delete the gene that is needed to respond to interferon. So normally, in most viruses, you would expect this to be very harmful because interferon is a major part of the response to crush the virus. However, as I just told you, in SARS, it can be completely distorted and flipped around. So what happened was, in these mice, when they deleted the gene for the interferon response, if they gave the mice an otherwise non-lethal dose of influenza, the mice died. Okay, so deleting the interferon response caused a non-lethal dose of the flu to become lethal. On the other hand, Deleting the interferon response caused them to be able to inject an otherwise lethal dose of SARS, and the mice survived.
Wow.
So if you can have something as central to the response to viruses in general do the completely opposite thing to the lethality, to the risk of dying or not dying from the flu versus SARS, then the last thing we want to do is just assume that everything that worked for the flu will work for COVID-19.
Yeah, it's so counterintuitive because by deleting the gene that causes the mice to respond to interferon, it would seem like you're actually like deleting, in a sense, their immunity, right? But actually it showed that by doing that, they basically seemed to be, they were protected against SARS-CoV-2. Or the SARS.
This was the
SARS-1.
first SARS virus. Yeah. Right. And so what that shows is that, first of all, the thing with interferon is, first of all, the virus is evading it and suppressing it anyway. And so the natural ability. Now, okay, here's the question. What happens if it's suppressing it and evading it? What happens if you treat the person with interferon? Well, if the person can't make their own interferon, but you treat them with interferon, maybe that helps. However, that was a major treatment for SARS. The WHO contracted CDC to study all the treatments. CDC looked at the 3 studies on interferon and said inconclusive. Okay, now in China, they were treating everyone with nebulized interferon, but there's no studies on it. Everything that they've been treating people with, there's basically no clinical studies on it. So we don't know if it worked for SARS, and we don't know if it worked for if it's working for COVID-19 where it's being done. But what we do know is that the body's own ability to produce interferon is being undermined. And so you're not doing that much to hurt the initial immunity if you're deleting something that wasn't working anyway. But then if that thing is the thing that ultimately plays a role in killing you later, then of course deleting is going to help you out. So anyway, I mean, to pull it back to nutrition, that's basically a reason to be exceedingly cautious about jumping to conclusions from things that worked for other viruses to this one. And I brought up A and D, so I just want to make one final point. This COVID-19, this virus, is one of only 3 viruses out of all the known viruses that are known to enter cells by binding to a protein on the cell surface called ACE2. And ACE2 is a protein that otherwise has a completely unrelated positive health-promoting function in the body. But in this case, it's the door that allows entry of the virus. And I looked for, one of the things that when I was thinking about what do we do for nutrition is I screened everything that might be potentially useful. And I said, what does it do to ACE2? And so there are a number of animal studies on both vitamin A and vitamin D that suggest that both of them increase ACE2. Normally, that's a good thing. But when it comes to a virus, a good thing's not always a good thing because viruses hijack good things and they do bad things with them.
Wow.
So I've gotten a lot of criticism over this because people have said, well, we don't have clinical studies in humans showing that it's doing this. You don't know that it's going to worsen the disease risk. Of course, I don't know anything for a fact, and neither do you, and neither does anyone else, because there's no clinical trials of anything. So the point is, what do we do now? Well, at a very minimum, we rescind what would have been my normal intuitive response, which would have been to just down lots of vitamins A and D, right? At a minimum, we say, don't take any more than you need to for other purposes. So I'm not out there saying everyone stop getting any vitamin D. Don't go outside because you might make vitamin D from the sun. But what I am saying is, be on the conservative side. If you are taking vitamin D for no particular reason, you should probably stop. If you were planning on taking high dose vitamin D to treat this, you should definitely avoid doing that. But if you have a problem that you're solving with 2000 IU of vitamin D, I'm not telling anyone to get rid of that, right? So if you have a good reason to be taking a certain dose of vitamins A and D, especially if it's for a medical problem that you're fixing, but if you have a tangible, perceivable benefit that you're getting from that, I think fine, stay with it. But on the other hand, if you're overshooting the dose on completely theoretical reasons, then I think, I would say now is a time until we know more to be more conservative with that dosing. So I think that, getting the RDA for these maybe going a little bit over the RDA for vitamin D since it's so controversial, but not going into the range of high doses and, unnecessarily supplementing, I think is a very wise piece of caution to take right now.
I think we're at a perilous moment, and the only thing that I can think of to help us see our way through this begins and ends with conscious, long-form conversation, like conversations that matter about important things with a priority on nuance is really the cure to what ails us.